Hi everyone, welcome back. What we're going to do now is go through our RStudio analysis pipeline. I'm going to show you how to deal with that double tap problem that I mentioned in the previous video. We're also going to show you how to make these really beautiful plots that you can see in the bottom right hand corner using a program called ggstatsplot. So as we go up here, I'm going to go through the kind of fundamentals of all the R scripts that we've been working with. To start with, we have our libraries, and these are packages that you have installed in RStudio that come with different functions. dplyr or dplyr, never quite know how to say that, is a pretty essential function for doing data analysis and data pre-processing. It's got loads of great tools in it like the filter, select, mutate, summarize, all these kind of functions which are incredibly useful for data pre-processing. String R is also quite useful if you need to do any kind of text editing or using kind of matching based on text codes, things like that. And the other thing we're going to introduce today is ggstatsplot, which I really love. It's a beautiful program, really easy to use. As I mentioned, I usually like to start by removing everything from the workspace. You can see at the moment, because I've run the scripts, we have information in here, but I think it's always good to start with a clean workspace. We then set our working directory, and the first thing I'm going to do is load our two tasks. We have the fixed SART, which is going to be one text file, and then we have the random SART, which is another text file. The only other thing I've done here is create three empty variables that we're going to call upon later, a kind of task data, which is the big final variable, and then we also have two other data frames, one called task data F and R for fixed and random. The next thing I like to do is this kind of nested for loop situation. So the first for loop, which we can see here, basically runs the same bits of code for either the fixed data or for the random SART data. And it just basically says here, if you're on the first time in the loop, then data should be the fixed data. And if this is your second time in the loop, then make the data random. The random data I should be specific about. We then find all of the different ID codes in the file, all the unique ID codes, and how many unique ID codes there are, and this helps go into our second loop, because the second loop identifies each individual subject. This little bit of code here is very similar to what you will have seen on the pivot tables, when we take participant ID and we drag it into the rows column, and it gives us a row for each one of the unique ID codes. That's basically what these couple lines of code are doing as well. Now in this next for loop, what we're going to do is we're going to isolate each individual subject, and we do that using the filter function. Another thing to do as well, because we have three groups, this is a good opportunity to figure out which group the participant falls into. Were they part of the MCI dementia group? Were they part of the elderly group? Were they part of the young group? And we can get that information by pulling the first row, the first element, from participant starting group, which tells us which type of participant they are. This is then an example of piping, and what we do is we pipe multiple processes into one function, basically into one set of commands. So what we say here is select these columns, which are the columns I'm interested in, filter so I only have columns with the word response inside the zone type, also filter so I only have elements from task. I want to get rid of the practice ones. And then we talked about the double tap problem. And I'm sure there is an elegant way to do that in Excel, but you can see here in RStudio, or R scripting, we just use one function called distinct. And basically distinct says find all the unique trial numbers. So if you had that situation we saw beforehand when a double tap meant even if you used attempt equals 1, even if you filtered it for just the practice trials, you would see multiple presses for the same trial number. This gets rid of that, and it just keeps whatever the first response is. Now this is fine for what we're doing because we're not looking at reaction time. Taking the first response might not always be the best option. You might want to take a response, there could be multiple double taps, but the first tap could be really too quick to be realistic. So you might want to think about that as well. For our needs, just this one line is absolutely perfect, and we can only take one tap out of multiple taps. We then basically convert the data type, and I'm going to talk more about this in a second, because as we do the analysis here in R, then it's important that we define each one of our variables. Is it a character? Is it a number? Is it a factor? And in this case, we're using the factor variable to say that the response type, correct or incorrect, is a factor. So there are two levels, correct or incorrect. And by defining this as a factor, we can use the next variable called summary. And summary just counts out the number of times each of those labels is used. So how many corrects are there and how many incorrects are there, which is exactly what we're looking for. What we then have is just a little loop, because there were those situations, and we saw it in Excel as well, where there was a blank field. And that blank field was basically when somebody either basically they didn't make a single response. So there are either no correct trials or there are no incorrect trials. And we saw a couple examples of that in the data. One example where the person got the task the wrong way around, so they only pressed on a 3, so under correct it was blank. We also saw some examples of this in the incorrect, where people were just perfect participants, and they never pressed on a 3. But if they've never pressed, then you never have a correct or an incorrect. And when you have that with the summary function, it reports what's called NA, or not a number. So what we've just done here is a little statement that says if the value inside here is NA, is not a number, then omission errors should be 200, because it means they never pressed when they should have. So that for the 200 trials they were supposed to press a button, they never did. So omission errors, which is not pressing when you should press, is 200. Otherwise, else, what we do is we say 200 subtract the number of times they pressed. And this gives us an omission error number to tell us how many times they withheld a response when they actually should have made a button press. We now have the same if statement here, but looking at the commission errors. So this is when they press a button when they shouldn't. And this one's a little bit simpler, because we say here, if the incorrect has no value in it, it's an NA, that means they were perfect and they made no commission errors. So CE should be 0. Otherwise, CE should just be however many times they pressed and how many times we saw an incorrect label in the dataset. The last thing to do here is just to summarize that data and combine our ID code, the group, omission and commission errors, and add those into these two empty task frames. So we add them in for each subject. We can label those variables, so we call column 1 ID, column 2 group. This is useful as well if you want to do the analysis inside of RStudio, or if you want to save out the data and do the analysis in JASP or Jamovi or even SPSS. Adding these labels will just help you know what each column actually is. The other advantage, though, of adding these labels is you can use something called the merge function. Now, the merge function is really useful because what it does is it takes two data sets and it takes a common identifying key, such as the ID code, and you basically say merge these two together using the ID code. When we do this in Excel, I always tell you to make sure you have the ID code when you copy and paste across different sheets and different data sets, so you can manually compare ID code to make sure that your rows are correct and that you have the correct data assigned to the correct person. Now in RStudio, you just use merge. The merge does that for you, and it makes sure that you basically the data is aligned based on this common key, such as the ID code. Now here again, we're just doing a little bit more work in making sure our variables are the right type. So we make these variables different factors, and we make these numbers as integers. And if you ever wanted to see what the data looked like, you can use a function called str, which basically is the structure, and it will tell you what each one of the columns is inside that data frame, and it will tell you what type of data they are. If you want, as I said, write this out and you can work on it in JASP or another program. What I've done today, though, is I've used this ggstatsplot. ggplot is one of the best tools to learn how to use in RStudio. It's called upon almost always, and it creates these beautiful different plots. And GG stands for graphical grammar. It's a great tool to get used to. If you're going to do anything in data science, you're undoubtedly going to be using that. ggstatsplot uses the basic ggplot architecture, but it also runs statistics, and it's got such a wealth of functions to it, which is really amazing. So here I'm using the gg between stats element because I'm doing between groups statistics, and all I have to do is define the data, whatever my x variable is, in this case the different groups, my y variable, which is in this case fixed commission error, I can give it a title, and then if I want I can define the type of analysis I want to do. Now I know from when we looked at this in JASP that we don't meet the criteria for parametric statistics. It fails in Levine's test, for example. So I've said type NP, which forces it to do a non-parametric ANOVA. And we can see all the results here, if you look in the bottom right, inside of the plot. Not only do we get this beautiful plot which has the box plots, the medians, we see the individual data with these points inside, but we also see what's called the violin plot. The violin plot basically shows here all the participants are scoring around this area, so they're all scoring here, so the violin is fat, meaning if everyone is here. When the violin is thin, it means there are few or no examples in that place. So it shows us, for example, the really quite diverse distribution of results in our MCI dementia group compared to our young and elderly populations, which are much more constricted. You can see, as well as having the Kruskal-Wallis score, which is our non-parametric ANOVA, it also gives us the post hoc tests. And you can see at the bottom it's Dunn's test, and it only gives us the comparisons that are significant. It's not showing us a non-significant comparison, meaning that the only significant differences are between MCI and old and young and old, not between MCI and young. And that's a little bit different to the analyses that we had in JASP before we got rid of the double press, for example. So it's shown that the young and the MCI are actually much more alike, both in the fixed SART, and if I click on the arrow here, it will also take me across and show me an error. Oh dear. There we go. I was a bit too keen, I pressed twice. Double tapping again. But here we can see the random SART, and we can see very nicely, again, that the random SART, young and MCI individuals have the same level of commission errors. Elderly individuals are actually performing the best. So I'd recommend, have a look at ggstatsplot. It's a great tool to use with lots of functionality and lots of information. And like I said, these plots I think are absolutely beautiful. But with that, you can see a couple little bits of code. We fix our double tap problem, and we get these really beautiful plots and analyses at the end. So hopefully that's going to encourage some of you to start working with RStudio. Otherwise, don't worry. We've got our Excel pivot table and our analyses in JASP, which are just as good. So thanks very much for this. I hope you enjoy it. Download the data and start playing with it all for yourself, and look forward to seeing you on the next Gorilla Academy.